So can you see my screen? Aditya?
Yeah, I can see your screen.
So, hello everyone, welcome to weekend programming sessions, group 2. This would be an introductory session, and this we will see what all we will be focusing in group 2, and we will end up with like some riddle puzzles and some problems from core courses. So let's get started. So yeah, as you would want to know, since you might be planning to join G2 or you are in G2, so what you can expect at WPS G2. So we'll provide you resources, sessions, and problems for some concepts which are generally uh, tough to understand yourself in competitive programming. Some things like we'll start with binary search and dynamic programming and start learning graphs and a lot of graph related algorithms like binary listing and segment tree and a lot of things that comes with it. So we'll start with recently moderate topics like dynamic programming and basic concepts of graph. But the main aim is to go towards higher advanced algorithms like segment tree, flows, something like two-stat, and a lot of things. So this is more or less focused towards learning, starting learning topics which are basics for uh, even advanced topic, and then eventually we will learn topics which are um, considered to be one of the hardest in competitive programming. So again, you can find a like you can expect to get resources, sessions, and problems on them. We will be focusing more on standard problems for the basic concepts that that are there. And as we go, like after a few months, when we will reach some even advanced topics, you can expect some hard problems which are like in particular made for that kind of topics. So that's the plan for group 2. We will have session every weekend from 4 to 6 p.m. For group 2, we will be having a session on Sunday, and obviously we will not have session during the end semester. So after each session, you will get some problems about the concepts that are being taught, some standard problems, and some tough problems as well. We would be you can expect you will get around 10 problems every week, um, 6 to 7 of moderate difficulty and 3 to 4 of hard difficulty. And your task would be to complete at least 3 of them and attempt at least 5 of them. So this is the task you would be supposed to complete in the next 10 days. So in the next 10 days, you will get like 1 week to solve the problems. And in the next session, we will be discussing the solution to some of the problems that were given. So in the session as well, you can learn. And after the session, you will get 3 days to solve the problems again. If you want to give them a revisit or if you learn something from the session and you want to re-implement. So that way the session would be helping. So some part of the session will be focused on solving the previous session, like previous week problems, while in the later half, we will be learning some new concepts based on which you can do new problems in the upcoming week. So that would how a session and the problem solving would go hand in hand. And yeah, you can expect the problem would be of good level because this is good too. Uh, if you get any queries, you can just raise your hand after this part is over. I will get to the queries. So what would be the features of the group 2? So there will be session. You can expect a session every Sunday. You will get problem sets to after every week. So you will get around 10 to 15 problems to solve. So I guess if you solve just 10 problems every week, then you would be solving some 500 good difficulty problems in a year. So there is something which is kind of we want to make it habitual inside everyone. And again with the WPS, you will get doubt clearance. You will have the WhatsApp group, so you can ask your queries there. There would be others with the same mindset and even us who would be there to solve your queries. And again, the best way to check the skills you have learned and to implement them in a competitive environment are contests. So you would have a contest after every month, except the first month because there are entrants. So that way you would be able to check the skills that you have gained. For contest and for most problem solves, there will also be prizes. So that you can keep yourself motivated to solve more and more problems and do better in the contest. So this was what you can expect. Now coming to what we expect is uh, you will be exploring a lot of advanced concepts. So we would recommend you to have some good experience in CP, or at least you would have solved some good number of problems. So I guess somewhere around 100 or 200 is kind of what everything you should have solved up, so that you can directly go into the advanced topics and get familiar with them. So we expect you should have solved some good level problems, or you should have some good rating on some platform. If you have either, I think you would not face much difficulty in this group. Uh, yeah, if you are very familiar with competitive programming environment and you have solved a lot of problems. That's one thing. If you still need some basic reference to C++, something to topics like standard template library, or some topics like modular arithmetic or something, we had conducted a summer programming camp in the month of July this year. So you can find the material related to the same here. I don't think you would need a lot of it because you're applying for group 2, but still in case you want to revisit some topic related to C++ in particular, if you are using some other language, or you want to learn something like standard template library in C++, you can go through these videos. We'll provide the link to the session. We'll provide the slides so you can find the link to the drive here. You can also find some problems that were given during that time. So in uh, in aspect of each and every topic, so you can find them here. So, and you can find the solutions to them here that were explained for all the problems. And if you need, like, if there is anything you need to know to solve the problems, you can find them in the sub. That's regarding the questions you will have. And there were some few contests that were conducted as well, which you can find attached with the in the drive. I guess a lot of, like, most of you would need it up, but still in case if someone wants to revisit, they can use it. So this is about that. And so again, this is for experienced programmers. So we think you might not be able to need to go to the drive, but still in case you need, you can go. And throughout this event, we will be giving you tough and challenging problems. So you can expect a roller coaster ride. You might not get all the problem, but we would recommend you to at least try out all the 10 problems that are being given for a week. But yeah, we will ensure the difficulty in a way that in a week span, if you just give a half an hour to 1 hour every day, you can solve all the 10 problems. And again, the compulsory task is to solve at least 3 problems and attempt at least 5 problems. I guess we will give more details about that later on, so it will become familiar with them. And this is what we expect you to have before the event starts, know before the event starts. And what we would want from you after, like when the event goes on, is that you are sincere in problem solving and you complete the task that has been given. So we don't expect you to solve all the 10 problems. We know that like someone might not be able to give that much time, or they may not be very familiar with the difficulty level. But yeah, we expect you to attempt at least 5 problems out of the 10 that are given, and get solved at least 3 of them. So that way, we want you to complete these tasks after each and every session is conducted. So for each and every week problem, we should be able to complete the task that can be given. And we would want you to give full sincerity in this and um, solve up these problems and the associated materials that we gave you to read up. And this is something in which we would want you to show your full efforts. It might not be able to, it might not be possible for you to solve up all the problems. But again, we would ensure that the tasks that have been given as compulsory would be something you can do up in the week's time. And again, we would consider the quizzes and exams So if there's anything that's during the week, there would be relaxation in the task. But again, we expect you to give the full from your side. If you just want to watch the session and see the problems, you can get the link to the session from Smail. So you can just come to the session and watch up. But if you want to get the queries solved and want to be a part of a healthy culture, you would have to solve all the problems. That is something we would expect from you. And I guess this is something we would be very strict about as well, because this is one way for us to ensure that the learning we are giving is reaching successfully to you. Because in online exam, it's a bit obvious for, like, it's a bit easy for students to get off track and get into a chain of procrastination. So this is what we think is a nice way to ensure that it does not happen. So yeah, I guess this is what we would expect from you overall. Coming to the schedule of group 2, we would start with binary search in the session that will be conducted at the end of this week. And after that, we will go to dynamic programming, two pointers, trees, graph traversal, shortest path algorithms. So, and minimum spanning tree. So these are kind of the basics of uh, graphs and dynamic programming. I guess these two form, like these two are used up a lot of places in future. And after that, we will cover some topics like TSU, some string algorithms like KMP, Z, and string hashing. And after that, we will move towards a bit of advanced topics like binary listing, LCA, segment tree, flows, and two-stack. So there's a lot more to come up, but I guess first part of it, which is the graph and uh, uh, dynamic programming part, that would be covered for first 2 months, and after that, we would slowly go towards even advanced topics. Okay. So I guess this is about the schedule. There's a lot more to come, but I guess it's not pace won't have been sufficient. So coming to what is CP, I hope most of you would be knowing. That's why you have come. But like why this slide is there is to tell you or to remind you about why we do CP. So again, there are some academic benefits or something you can look for, but like something you might want for. But again, what we would recommend is just try to do CP for the fun part of it. Try to enjoy it as you would have enjoyed any other sport. So try to focus mainly on that. Because only if you enjoy something, you would be able to do it out of yourself. You won't take it as a pressure, and you will even do much better if you would if you would do it for some other thing. Just try to do it for fun, and again try to ensure that you don't let any other activities of your effect get affected because of it. So again, don't get addicted to it as well, which is what I've heard from some of the students. So again, to make a right balance is important in anything you do. So, but yeah, with if you get interested in CP and you do a lot of CP, there's a lot of benefits as well which you will get. It will boost your problem solving skills and logical thinking. It will give you a lot of self confidence in problem solving. You can enjoy it and you can do it as a fun activity, just like you would do some play some other sport. And again, that fun of getting that accepted is kind of what makes you crave for more and more problems. Again, where you can do CP, I guess most of you would again be knowing up, but yeah, you can do it on Core Forces, Core Chef. And if you do CP consistently, we would recommend you to have a look on the contest that goes on worldwide. Some contests like Google Code Jam, Kickstart, Facebook Hacker Cup is something you can look for. If you want to represent your country in competitive programming, you can look for the International Collegiate Programming Contest, which is the Olympiad in CP. They even gave gold medals and like silver medals for ICPC. So it's considered to be the Olympics in competitive programming because it is a sport, if you see. So, but yeah, that's on a bit harder scale. So you would have to prepare a bit more if you are looking for that. CP again, like it's more or less about practice you put in. You need to do a lot of practice. But if you do a lot of practice, like you would go ahead and you would get a lot of learning. So just try to make like push yourself 1% every day, make yourself better by 1% every day in CP in particular for now, and you would see the result by the end of the year. So just try to put in some efforts, learn something out of yourself as well, and focus on enjoying it as much as you can. And believe me, if you just put some time on it, and initially it can be a bit difficult, but with time you would definitely enjoy the problem solving aspect of it. Irrespective of whether you are able to perform good or not, you would enjoy the problem solving. And that is something which I think you should focus on. Again, not everyone might not be able to get good ratings or good rankings, but getting the fun aspect and enjoying the problem is something which is independent to everyone and everyone can do. That's something which we always recommend you to focus on while doing competitive programming. Just enjoy the problem solving part of it and do it for fun rather than focusing on anything else. I guess this is all about competitive programming and what G2 be more or less about. I guess you would have got a good idea of it. If you still have any queries, I would recommend you to raise your hand and ask your queries. I can go to chat as well, but it's a bit better if you speak up. If you have any queries regarding to what G2 will be about or anything in general, kindly raise your hand. I guess there would be some queries. So like anything regarding what we would be studying in future. Again, you can expect some good level problems. So not just topics we would be studying, but like topics would be more or less a bit on the moderate side. But the problems that would be given associated to them and some random problems that would be given would be on a tougher side. So if you are a bit new to CP, you would find it a bit difficult. Okay, I guess if there are no more queries, then we'll go to some riddles. This is one riddle I guess a lot of you would be knowing around because this was something we had asked in yesterday's session as well for group one. But the problem by its nature is so interesting then that I feel it hard to not share it up. So uh, I will go through it once. If you are someone who attended yesterday's session, just be with us for 10 minutes. I ensure you that today it won't we won't take it up for more than 15 to 20 minutes. So I will just go through the problem once. So basically, Alex and Bob are playing the game with stones. There are two piles of stone. The left pile contains X stones and the right pile contains Y stones. And they play the game in turns. And X5 is greater than 0. In their turn, Bob and Alice will remove some non-zero number of stones from one of the piles. Just focus on this non-zero and from one of the piles. The person who removed the last stone would win the game. That is the person after whose turn the other person will have nothing to move on. So Alice will start first, and assuming both the players optimally, you need to predict who would win. I guess I would. So yeah. So this is Alice and this is Bob. It can be you and me as well. So there are two piles of stone in between. In one pile there are X. So there are two piles in between, piles of stones. One has X stones and the other one has Y stones. And in their turn, Alice and Bob will move alternately. Alice starting first, and in their turn, they can remove some finite number of stones from either of the pipe. And your aim is to win the game by removing the last stone. That is, after your turn, the other guy should not be able to have any stone to remove. So he can't make any valid move, so he is lost. Your aim is to remove the last two. And given the initial setup, you have to predict who would win. So to start from basic, consider there is just let's consider there is just one pile X which has some number of stones. Say there are 5 stones on it. Now, if Alice and Bob both play optimally, we need to predict who would win. Anyone here would like to volunteer for it? I expect you were not in yesterday's session or you don't know the solution. So there are 5 stones in between. Alice and Bob will play. Alice will start, and in their turn, they can remove any finite number of stones. I guess this is a simpler version of the problem, so you can answer. Okay, no answer for this version. Or is it like all of you were in yesterday's session, so you are not answering? Okay, can I know who all were there in yesterday's session? Like, can you raise your hand if you had attended yesterday's session for Chief? Okay, I guess there are 6 people. Oh, I guess it's fine. Like out of 55, we have 6 who were there. I guess there are still a lot of people who were not there, right? Thank you. You guys can raise your hands down. So maybe I must take someone granted. Okay. Yeah, Araj, can you unmute yourself? Ah, okay. I guess there are some issues. Fine. Okay, I won't take Sukhit. Yeah. Vineet, can you unmute yourself?
Yeah.
Yeah. Do you know about this problem? Like some general variation of this problem?
No, I haven't heard of before.
Okay, okay. Then it's nice. So suppose there is just one pile of some X stones in between. You know the game rules, right? In there,
Can you show that again?
finite number of stones from the one of the pile.
Okay.
Your aim is to remove the last stone. Then who would win?
We have 2 piles, right? Or a single pile?
There's just one pile for now.
If there is one pile, then can we remove all the stones in the first attempt then?
Yeah, you can remove any finite number of stones.
Our task is to make the pile empty so that other person cannot have any stone. So then, if we are allowed to remove any number of stones, then we can remove all of the stones.
Okay, yeah, that's correct. So in their first turn, LF will remove all the stones and she would win, right?
Yeah.
And so the strategy is like go first and remove all the stones. So the one who would go first would always win, right? Okay. Let's consider there are 2 piles, X and Y. Suppose X has 5 stones, and Y has 8 stones. Like, who do you think would win now?
Okay.
You just make one of the pile empty, then another guy would win. You can't use the
Yeah. We cannot make one of the pile empty. So.
let's try to play the game once.
Do you think each person will remove one stone at a time from?
Okay, so let's try to play the game once. Would you like to go first or would you like to go second?
Oh, okay. I would like to go first.
You are V1 and so what's your move? What would you do?
Okay.
Do
I
something.
would remove 3 stones from it.
It will become 2, right?
Yeah.
Maybe I would remove 6 stones from Y.
Oh.
It's your turn.
Hmm. I'll remove 1 stone from X.
Okay. Maybe I will remove 1 stone from Y as well. By the way, it's not like you have to remove from X only. You can remove from Y.
Yeah, got it. Yeah, and now I think I don't have any other option. If I do anything, then can we play this again? I think now I got the
So did you got some strategy? If yes, then I will play with you.
I think we are trying to make both of them equal. Like 500. If I have done Y as 5, then
Okay, then what would you do after like making it 5 and 5?
yeah. If I make 5 and 5, then it will be your move again. So in your move, if you make X or Y like some set, then I will try to make the other one as set.
So basically, I think it's a strategy. So we make both of them equal, and now whatever the other guy moves to one of the pile, you can do the same thing to the other pile. And since the other person was able to make some move, it's definite that you would be able to make the move as well. And eventually, the other person will get 2-0. Yeah, this was the strategy. So I get that you got it up pretty quickly. Let's play it with 3 piles. What do you think?
Okay.
Aditya, can you make the game setup?
Yeah, sure. Give me a minute, share screen.
Yeah, yeah, sure. Maybe I will just.
Is my screen visible?
Yeah.
Okay, good.
So
Now 3 piles, right?
yeah, 3 piles. You can tell some 3 numbers. Vineet.
Okay. Any numbers? 7, 8, 9.
Let's start with it.
Yeah. Okay.
Would you like to start or should I start?
Yeah. I think I'll start.
Start. Meanwhile, others can try to figure out what the strategy would be, like optimal strategy to play when there are 3 piles. I hope 2 pile strategy is clear. Just make them equal. So we can try to play one game. Let's see if that helps.
Okay. I will empty 1 pile.
Then I would win, right? Any
If
of
you
the
empty
pile.
1 pile, yeah, then you will start. Okay. Yeah. That is also
Just
good.
try to do something which does not gives you apparent law. Okay, anyone else who would like to play can also raise your hand. After that, we can try that. But again, if you know the solution or something, then yeah, definitely no. I wonder there are no others like who would want to try up or something. I guess I can see a lot of familiar names, so I get that that could be one reason. You should have not attended yesterday's session, Jayaki. Let's play one game, Vinny.
Yeah, okay. So yeah, I will go with I will make 8 as 7.
Then I think you know what my move will be, right?
No,
I just
be
make
like
9
make
zero, and it's
you will
7.
make 9 as 7.
I will make 9 as 0.
0. Okay. Yeah, if you make 9 as 0.
Now I think
Okay.
that's the movement right here. Would you like to
What if
replay
I
the
make
yeah.
what if I start with 7 as 6?
What? What are you starting with?
I will make 7 as 6. Yeah.
Okay, that looks like a good move. Maybe I will make 6 to 1. 189.
Then I'll make 8 to 7.
179, is it?
Yeah.
Make it 176.
One five six.
Okay, I think you got something in the technique. 154. It's your turn. You can't touch the one pile
Yeah.
two game and that kind of
Yeah,
possibility.
if I touch 1, then it will be wrong. I cannot make. Essentially, it should be everything should be non-zero after that. Files will be. I'll try. I have choices as I'm making 5 as 2 or 3. I'll go with 5 as 2. 1, 2, 4.
I think I am fine with the submission thing. So 1, 2, 3. I guess now Jay Kamal would like to play. Anyways, yeah, you can continue when it's your turn.
Okay. Yeah, I think no choice. I don't have any other choice.
So what would you do?
Whatever I do, you will win now.
Okay.
Uh,
Would you like to restart or like find something which I'm doing up?
yeah. 1 second. I will try to find out what you're doing.
Meanwhile, anyone else who would like to give it a try?
You're trying to make common differences fun.
Could be the case. Not sure.
Differences. Oh, or the same common difference.
Yeah, I guess you are close, but
Okay, yeah. Not same common difference, but first you made it as 1. Yeah, I guess. But that doesn't say anything because I could have made that 1 as well.
maybe you would like to start again or something.
No. Like just let me get this. Maybe in math I missed. Okay, this time will you start? I mean,
What?
will you start like?
Yeah, I would like to start. Fine. Let's start with some big numbers as well, or the same numbers.
Same number for this.
Hmm. So, okay, yeah. So maybe I will directly make it to the second one, 189.
Okay. I will do 187.
Okay, something new. 167.
127.
127.
27. No. Wait. Not 127. Uh, it is ultimately becoming 123.
Let's try something.
Yeah, 164.
164.
Now you do 144.
No, I will do 154.
Yeah. That's what I'm saying.
I want to make the same move, right?
Yeah. If I do 144, then you'll win. If I do 134, even then. If I do 134, then again you will have 123. I think again you win.
Okay, so you accept your defeat.
Yeah.
Okay. So eventually I would have taken more people, but I guess neither a lot of you are willing, or I guess probably a lot of you would also be knowing. So maybe I will share uh, uh, what the reason was. So basically, it's a standard game which is well known. It's called a NIM game. You guys can search about it. And I was playing it using a small code that I had written. So, like, I would type it in the move that Vineet would play, and I would get what move I should play. So it's kind of a fun way how you can use your programming skills to defeat your friends. But yeah, basically it's a known game. We would share the code as well. Uh, I guess for now I will just share the link to it. Hmm. Hmm. Yeah. I shared the link to the game in the chat. So that's I guess about the game. And so basically that the algorithm has to do something with XOR of the piles. It can actually be played in general as well when there are n piles. Uh, some part of your yeah. So basically you can see that a lot of times my moves are somehow relating to the sums of them. That's why because bitwise XOR, like if there are no bits which are same, can also be like results into the sum of the two numbers. So, I shared the link to the algorithm as well that you can see about how it comes off. It actually have a pretty famous website called CP algorithm. So that would uh, tell about like how exactly you can also play the game with your friend and win. Yeah, I guess it was nice playing with you. Thank you, Vineet. So, yeah, thank you, Aditya as well. I will go on to the
Yeah,
next
that's sure.
problem now. Yeah. So, so this was a stone problem. I guess you guys would be able to see my screen. So yeah, you can read more about it on the link. I guess you would get to know a good learning out of it. You can get a good learning out of it. So this was about that. Let's play the next game. So it's the 65 demons and one man. Um, yeah, it's also a bit known game. I'm not sure if some of you might be knowing. So if you know the game, I guess don't write the answers in chat and all. I would like to play it with people. So, so there is a village in which there are 65 demons and one man. So it's a bit cruel place for the man, but it is what it is. On the gate of the village, uh, there was an apple, which apparently the man went to exit the village and eat. So he ate the apple and just a second. Yeah. So there was an apple at the gate of the village, and which apparently, when the man was exiting, he ate the apple, and the apple showed its magic, and the man went into an eternal sleep. So, about the apple, the demons were knowing, but the man wasn't. So, this is the man, and he is into an eternal sleep. And now the rule of the game follow. So basically, all the demons know about this thing that the man is sleeping, and since he had eaten that apple, anyone who would eat that apple would also go into the eternal sleep. So if one demon comes and eat the man, he would he would have eaten the man, but instead now he would go and sleep into like get into an eternal sleep. So anyone who comes and eat, he would be next who would be sleeping. And each demon is pretty intelligent, and the priority for each demon is to save his life. And if he can save his life, his next motive is to eat a sleeping body if he can. So demons can't eat anyone who is alive, but if he is sleeping, they can eat him. And sleeping is considered to be alive, so they are not dead when they are sleeping. So uh, These are the rules. So there are 65 demons and one man. The man is sleeping right now. Any demon that eats a sleeping body will sleep himself. So it includes a sleeping man. And if a demon goes and sleep, other demons can also eat him. So only one demon will eat, and if he eats, he would be the one who will be sleeping next. All the demons are super intelligent and very hungry, right? So, but the priorities of each demon is first to assure that they will be alive, and secondly, if they can eat any sleeping body, they will. So, the question is that will the man survive or not? And if yes, how many demons will be left awake in the village? I hope the question is clear. Does anyone have any queries regarding the question or anything? If you have any queries or anything, you can ask. Okay. Okay. I hope the question is clear. So there are 65 demons, one man. The man is sleeping right now. And anyone who would eat the man or the sleeping body would sleep himself. All the demons are super intelligent and very hungry. And each demon's priority is first to assure that he will be alive. And after that, if he can eat someone, he will. So the question is, will the man survive or not? And if he will, then how many demons will be left awake in the village? If anyone wants to answer, they can raise their hand. I guess don't write it in the chat, just raise your hand. Aditya Vejalkar, would you like to give it a try? Just a minute.
Am I audible?
Yeah. Did you got the problem?
Yeah, I didn't understand when will anyone die?
Okay, so if a demon is sleeping and another demon eats him, then that demon is died. Like that demon dies.
That demon dies.
What?
That man dies, right?
When the demons will eat the man will die, and when some other demon will eat the demon who is sleeping, that demon will die.
Oh, okay.
You got the question, right?
Yes.
Okay. What do you think intuitively would happen? Who one would eat the man, is it? What do you think? Oh, I can't hear you, I guess.
Hello.
Yeah. Now I can hear you.
Then many demons eat the man at once also.
Only one demon can eat a sleeping body at once.
So if he eats, he will be eaten in the next chance.
What?
If he eats the man,
Hmm.
then the demons will eat him in the next chance.
Yeah.
So his priority for that he will be alive, then he will not eat the man. Maybe.
So no one will eat the man and the man will survive.
Yes.
Okay. Yeah, that's a nice guess. Maybe you can think on it for some more time. Does anyone have any other suggestions? Okay. Yeah. Okay. I guess if you have raised your hand for this particular problem, you might know the answer. So, yeah, Himesh, would you like to give it a try? Did you know this problem beforehand, or are you just trying out now? You can unmute yourself.
I'm trying it out just now.
Okay. So what do you think would happen first of all? Not going very far.
Okay, so I think only one person will eat him.
One demon will eat the man.
Huh.
And then no other demon would do anything to him.
Yeah.
Don't you think it's a bit counterintuitive? Like, why would only one demon eat someone?
So what I did is I started with one
Okay,
demon,
just
Oh, okay.
I just wanted to give some. Okay, yeah, I guess you can if you say it that way, you can say it up.
Huh? Huh.
Yeah, go ahead with what you were suggesting.
So I started with one demon, one man, and
Okay, what would
So-
happen for that case?
in that case, obviously the demon will lead the man and he'll sleep.
Yeah,
And
because
there's no other
demon in
demon.
the village,
Yeah,
so he will be alive, right?
yeah,
If there's one demon and the man is sleeping, the demon will eat the man and the game is over. Like the demon alive, but and there is no one to him eating. Yeah,
huh. So
that
he
looks
said.
correct.
Yeah. So the same thing, but now if there are two demons and one man, so if a demon decides to eat a man, he'll surely be eaten because the last remaining demon knows that there is no one else to kill him. So
Yeah. So when basically there is one demon and one sleeping body, the demon will definitely eat him, right?
huh.
Yeah. And now when there are two demons and one sleeping
Sleeping
body,
body,
they won't eat him because they
yeah,
know
no
if
one
they
will
eat
eat
him,
him.
the other guy would definitely eat them.
Yeah.
So when there
So
are two demons and the
three
man is
people
sleeping, no one would eat him.
following this pattern, yeah.
Yeah. So now when there are three demons and the man is sleeping, eat like anyone who is the closer or who gets to him would eat him because he knows when there are two demons, no one would eat.
Exactly.
That's why when there are three demons, one demon would go and eat the man, and he knows that he will survive. And similarly, now for four demons, they know that if they eat him, the three demon case is dangerous and they would eat the guy. So that's why for three demon case, for four demon case, no one would eat because they know in three demon they would eat. But for four demon, the sleeping body will stay alive, and then continuing the pattern for five demon, the fifth demon would eat. For six demon, no one would eat, and this is the odd even pattern that goes on. So for 65 demons, it's a bit counterintuitive, but yeah, exactly one demon would come and eat the man, and after that, no demon would do anything. Like for one demon case and two demon case, it looks a bit intuitive. Okay, what's happening? That yeah, one demon he would eat him, and for two demon he would not eat. But how the pattern goes on, and like for 65, for some numbers 65, it turns out that like uh, one demon would just eat, and after that no one would eat. It's a bit counterintuitive if you think like why exactly that's happening. There is a chain of thinking. It's basically in the mind of the demons now, right? Like that if they eat, they will get eaten, and if they don't eat, like kind of thing. I hope the logic of this problem is clear. Does anyone have any queries in this? I like this is a nice problem. These are a simple solution, but still I feel somewhere that it's a bit counterintuitive. Why in the hand, like in the end, still if I have to explain somewhere sometime, if I have to explain to someone directly that why at 64 demon no one would eat, it's a bit uh, like ununderstandable. Yeah. Yeah. Like that, are there any queries in the solution or anything? Okay. I guess if there are no queries, then if we move to problems, we will solve two core forces problems, which are apparently will be on a bit harder scale. But in G2, we will have a decent level, so there would be some moderate problem and some hard problems. The first problem of the day. So this is the problem. I will just read out the problem briefly. I don't know if some of you have already solved this up. If yes, then it could be a bit uh, like it would not be that fun. But I hope most of you won't have solved. So I will just read up the problem once. So Alice has a grid of size n cross m. Initially, all cells are colored white. The cell at the intersection of the ith row and jth column is denoted at si comma j. This is the standard thing. So Alice can do one of the following operations with this grid. Take any subrectangle containing the cell 1 comma 1 and flip the colors of all its cells. So maybe I will just draw it up. So suppose this is our rectangle. This is our n cross n grid. And similarly here as well. So yeah, this is our grid. So in in one operation, you can choose any cell that contain the 1, 1 cell. So this is 1, 2, 3, 4, 5, 6, 7, 13. This is the 13th cell, I guess. And then this is again 1, 2, 3, 4, 5, 6, 7. This is the 7th cell. So for the problems, like for this problem, this is n and this is n. You can in one operation you can take any subrectangle that contains the cell 1, 1 and flip the colors of the cell. So suppose you take this particular cell. This is 1, 1, right? So you can take any rectangle that contains this cell, this or this or this. So you can take any sub-rectangle like this and flip the color of all its cells. So this operation will cost 1 coin. Or you can choose any sub-rectangle that contains the cell n, 1, which is this is 1, this is 2, 2. You can take any cell that contains this particular cell. Yeah, this is so n, 1, and you can take any subrectangle that consists of this. So something like this or this. It can be till here as well, and it can be the complete grid as well. So choose any subrectangle that contains the cell n, 1 and flip the color of all its cells. So flipping the color as in if there is all white, so initially the grid is all white. So if it's all white, you will change it to all black, and like suppose only this and this one black, and you choose this particular subrectangle, then they would convert to white while all else would convert to black. So this operation would take 2 coins, and there is this operation. Choose any subrectangle that contains the cell 1, m. So 1, m would be this particular cell, and this would cost 4 coins. If you take any subrectangle that consists of this particular that contains this cell, then you can do it in 4 rupees, 4 coins. And then finally, if any subrectangle contains this cell, you can do it in 3 coins. I guess the problem idea is clear. These are the 4 operations which you can do with cost 1, 2, 3, 4. And you would flip the color of the cells that are there in that particular rectangle, right? There is a definition of the subrectangle which I guess is clear. So Alice wants to obtain her favorite coloring with this operation. What's the smallest number of coins that she would have to spend? It can be shown that it's always possible to transform. So basically you are given a grid. So consider in our original setting, this is 1, this is 2, this is 3, and this is 4. So suppose Alice's favorite coloring is this particular cell as black, this as black, maybe this, and this. So you want to achieve this set of coloring in the final grid, and these are the operations that you can do. In 1 coin you can change a subrectangle, in 2 coin you can change this subrectangle, in 3 subrectangle containing this, and in 4 coins a subrectangle containing this. Then what is the minimum number of coins you would need to change it from all white to this particular thing? Even like, does anyone have a query regarding the question? The question is explained pretty clearly. Write it in chat if you have any queries. Okay, I guess the idea of the question is clear. Okay. So yeah, basically this is our aim. So in minimum number of coins, we need to reach this configuration from white cells, right? I would start with a few insights. Before that, does some of you have any insights to the problem? Okay, what can be done or what can be done to simplify the problem a bit? Not exactly the solution of the problem, but something you think would maybe make it easier to solve the problem. Okay, Aditya, would you like to give it a try?
Yeah, I'm thinking.
Have you solved the problem or?
No, first time I'm saying.
Okay. So what insights do you get? Like anything you think would make the way to solve it easier? Aditya? I'm still with you.
Yeah, I'm still not getting anything.
Still anything that would make the solution like way to solution easier. Yeah.
Like,
Okay. Maybe you can start with. Would you ever use the 4-coin operation?
which operation? 4.
4-coin. So maybe I will
I
use some.
think no. If I want to do it
The
4,
four
maybe try to
conditions
use
that
1
add
itself and.
something like this. Yeah. Would you ever
I can
use?
probably do it without using a 4, just using 1.
Okay. So what would you do? So basically, a 4-coin operation would take a subrectangle like this and flip the color of all its cells.
To do that, we can just use 2 times 1.
Okay. So what would you do?
So 1 for the big thing,
First, you would change this and
then that one.
okay. So using this, in just 2 coins, in fact, you would alternate the color of this particular rectangle, right? Okay. So this looks like a nice observation, right? You would never use a 4-coin operation. So whatever you can do with using 4-coin, you could do that without using 4-coin in cheaper. Then the optimal way of converting the white cells to this, you would have never used a 4-coin, right?
Yeah.
Okay. Can you say this about some other cell as well?
3, maybe we can do something.
3.
Like 2 operation also, it's not necessary to be used because we can just use 2 ones.
Yeah, okay, that's also one nice thing. Yeah. Let's take that up. So any subrectangle, suppose like this, you would have taken. So instead of this, what you can do is use one this and one this. So this would also again take 2 coins, but now you have not used the second operation. So it's worth to note that whatever is the optimal answer, it can be achieved without using this 4-coin operation and without using this 2-coin operation. So now whatever we could have done in the optimal case can also be done using just the 1 coin and 3 coin. Can you remove the 3-coin operation as well? So suppose something like we need to flip the cells of this rectangle. Even if you can do it in 3 coins, I guess I would be happy to remove the third operation. But can you even flip this?
We require 4 coins, I think, to do it.
What would you do it in 4 coins?
The whole thing,
Let me
the
do it. So I would do first the whole, then
top, the horizontal top part,
okay,
then same for bottom,
okay,
and then I have to do it for the overlapping square.
okay. So in this way, this part got flipped twice, this part got flipped twice, this got flipped once, and this got flipped 4 times.
4 times.
So all the other parts except this part got flipped even number of times, which means they remain the same. So eventually, like overall, this rectangle is the only one which has flipped once. But this cost you 4 coins, right? It's possible that just a second. Yeah. So it's possible that in the optimal case, you would have used 3 ones, right?
Yeah.
Okay. So, but yeah, we have reached this information that we will never use 2 and 4, because if we want to do something like shift the colors of flip the colors of this rectangle, I would first flip this and this, which eventually means that these colors were not flipped and these got flipped once, right?
Yeah.
We have one good information that we would never use 2 and 4 information. So we would use 1 and 3. Anything else you think we can make up? Okay, so basically, if we go from white cells to these particular cells being black, right? Eventually, what would have happened is only these cells got odd number of flips. Like in the original white grid, only these 5 cells would have got odd number of flips. Rest, each and every cell got even number of flips, right?
Yeah, only then they'll be black.
Yeah. So yeah, you will be black only if you were flipped odd number of times, and you will be white if you were flipped even number of times, including 0, right? To reach from 0 to black, they should have been flipped odd number of times, and others should have been flipped even number of times. Okay, now consider the set of moves that I had used to go from white to black, white to this particular state, right? Okay. Now consider what would happen if I apply the same set of moves to this particular grid.
Can you repeat again?
Okay. Consider the set of moves, the combination of 1 operation and 3 operation that would have cost me something like k rupees. What happens if I use the same set of operation to this particular grid, which has these cells colored black?
Okay, so then everything except these cells will become black.
Okay, are you sure, or would you like to think again? The moves you had applied to that grid, you would apply it to this grid, which has these 5 cells as black.
Okay, there'll be even number of flips. No, okay, yeah. So all those will remain white, and the blacks go back to white.
Okay, so would you like to say it in some other way?
So basically, it goes back to initial condition.
Yeah. So basically, they will if you move like if you do the same set of moves again on this grid, these cells would get flipped even times again, which would convert them to white, and these cells which are black would flip odd number of times because you are using the same set of moves. So they will also get converted to white. So basically, the original problem is equivalent of saying that what is the minimum cost to convert this particular state to all white. Can I say that, Aditya?
Hmm.
Okay. Did everyone get that part? Like, are there any queries in this? Like, the number of moves or the optimal cost to get from white grid to this particular grid is same as the cost that would take you to go from this white grid, this grid to all white. Does anyone have any queries in this claim? You can write in chat or you can unmute. Yeah. Okay, I guess this part is clear. I guess it makes sense, right? So now we have three observations. We will never use the 4-con operation. We will never use the 2-con operation. And what we want to do is equivalent to changing this grid to all white. Because like now this sounds a bit more familiar, like a bit more convenient, right? You are given a grid and now you need to make moves on it such that all the grids, all the cells turn black, all the cells turn white. So this is now an equivalently converted problem using just operations like this and this. You need to convert these black cells to all white. So let's take an even simpler problem. So it's not true, but let's consider that for a moment, 3-cell movement is not there. Like the 3-coin operation is not there. So I'm making it dotted so we know that it's not there. It's not removed, but let's consider for once if that was not there. So we just have one operation which will cost 1 coin, or maybe you can just create one move, and in this you can flip any cell, any rectangle that starts from here, and flip the color of all the cells in this subrectangle. And even using just these moves, it is possible to go to the all white state starting from any state. You can believe me on that part. But yeah, that's also true. So if you just were given that in one move you can take any subrectangle that starts at 1,1, you need to convert a given grid with some black cells to all white. Now would anyone like to try what we can do or what we could have done? Like any suggestions, any ideas or any insights you have? Anything which you think could make the problem simpler? Okay. Teja, can you unmute yourself? Like, is it possible for you? Teja? I guess there is only one Teja in the room. Okay. Sukrit, can you unmute yourself?
I'm not able to think of any solution as of now.
Okay. But you got the problem till here, right?
Wait, can you repeat like why the two, like we can't, like we can exclude the 2-coin and 4-coin case?
Yeah, sure. That's nice. So suppose you were doing some operation in the optimal game. Just a minute. Yeah. Suppose in the optimal scenario to convert from all white cells to the given state, you at some stage used this 4-coin operation, right?
Yeah.
Now instead what I would have done is in the same game, I would have removed this 4-coin operation of yours and instead replaced it with this and this. So now what would have happened is all the colors would have remained the same and just the cells of this grid would have flipped, right?
Yeah.
So yeah, like these, like if you consider this particular rectangle, the cells of this rectangle got flipped twice in this thing, so they would remain the same color, while the cells of this particular rectangle got flipped just once, so they will be in the same color. They will get flipped, right?
Yeah.
Okay, so equivalent of doing the 4 move is to do this one move twice, like this move and this move, right? This would have the exact same effect on the cells of the grid.
Yeah.
Do you agree?
Yeah, agree.
Yeah, and now whatever the cost of your operation would have been, mine operation would take 2 coins less. Because you did it in 4 coins, I just did this, and I am done. I've achieved the same configuration after what you would have done for that operation in 2 coins. Do you agree?
Okay, so even for the case of 2 coins, you can just do it with, like, you can do the operation one twice. Yeah.
Yeah, again. So yeah, that was for
Okay.
4. Yeah, but yeah, I was just telling the 4 thing. So for 4, if you do the one operation twice, you would in fact get even a better solution, right? Our aim is to get done it in the minimum number of coins. The smallest number of coins I'll have to spend to achieve our favorite coloring. So the 4-1 would be in fact suboptimal, while if you do something in 2, that can be done with 1 in 2 coins. So that's definitely not a better thing that you have done, but you have proved that whatever can be done by using 2 can also be done without using 2, right? So this would take 2 coins, and this would have also taken 2 coins. So whatever you want to achieve by using the 2 coins can be done without it. So we have proved that there exists an optimal answer with just using one operation and the operation with 3 coins. Do you
I
agree?
got
Okay. Okay. And do you agree with the part that you will only, like, converting from white cells to this part is same as going from this cells to the white, all white?
Yes, yes, yes.
There is one more insight, I guess, which will help you to understand the problem, that the order of operations which you will do doesn't matter at all. This also looks like a bit counterintuitive, but this is true. So in any order you move, like you put the operations like 1 2 4 3 4 1 2 1 so and so on, it doesn't matter at all, because if you just see a particular cell, what matters for that particular cell is how many times it was flipped. If it was flipped odd number of times, it would change from even to from white to black, and if it was flipped even number of times, it would remain white. And number of times a particular cell was flipped just depend on the operations you choose, not the order you chose them. So if you try to do it, it feels a bit counterintuitive why the order in which won't matter. But yeah, we can see that the order in which you would make the operations, if the operations remain the same, won't matter to change from the initial to the final condition. Do you agree, Sukil?
Yes, yes, yeah. Like they're kind of superposing and like everything is kind of
Yeah,
mod 2 in each cell, so it does
yeah,
like the order doesn't matter.
yeah. So now
I
we have,
had one doubt, like what if you choose a subrectangle which contains like both 2 corners?
yeah, so you can do it with anything. So this thing or this,
But then like what would the cost be? Will it be 1 or 2 units, 4
you
units?
can do anything. So you can do this operation with 1 coin, 4 coin, 3 coin, or 2 coin. But since you want the
Oh,
optimal answer, you will do it with 1 coin, obviously.
okay, okay. I got it.
Okay. Okay. Um. Hmm. Soham, can you unmute yourself? If you guys have any queries and
Hello.
unmute, just write in the chat. Hello,
Yeah.
Soham. So,
Yeah.
are you with me till this point? Like, did you get everything?
Yeah.
Do you have any queries regarding why will not use 2 and 4, or why it's same to go from white to this thing is same as going from this thing to white, all white?
Yeah, that's fine.
Okay. And suppose we don't consider this 3 operations for now. What do you think is the main difficulty with the 1 operation? Like, do you have any idea of the solution? How we will go ahead? If you just
I
take
would guess that
operation,
if
yes.
you want to toggle one block,
Hmm.
then you might do a single operation from that point
and then another operation to the left of it, another above it, another to the top left of it, something like
But yeah,
that.
that would take 4 coins, right?
Yeah.
Yeah, that can be done, but it would take 4 coins. So for just one operation, what do you think is the major difficulty? Like suppose I want to do some operation like this.
Yeah.
So, what is the main difficulty of this operation as of now? Why is it a bit hard to get from here to the solution? Suppose in one move, I said you that you can do one move and it will only change one cell. Like in one move, you can toggle any particular cell of the grid. Then you would have said the answer clearly, right? Just use 5 operation and change them from left to right, right?
Yeah.
So what's the main difficulty of this operation now?
It affects too many blocks.
Yeah, it affects too many blocks, and so it's a bit difficult for us to keep an account of okay, what will happen in future if we do this and all that. So yeah, I guess that's what I wanted you to say actually. So this affects too many blocks in just one move, right? Can we do something, or can we change the grid into something such that in the transform grid, doing one operation affects only a uh, few cells, some constant number of cells, 1, 2, 3, 4. Can we do something like that? You can think on it. Yeah, okay. Oh, you got something. Oh.
I mean, kind of like what I said already, that you just affect, suppose you do it till m comma n, and then
But I
you
want
do
to do
it,
it in
undo
one.
the rest.
Yeah, go ahead. What are you saying?
I mean, basically undo the rest of the changes which you don't want. That would cost 4 coins though.
Yeah, but that would cost 4 coins. Yeah, we want to do it in a bit less coins. In just one move, basically, you want to, because again, here the cost is a bit of concern to us as well, right? You want to transform the grid into something, or like, yeah, you want to transform the grid into something such that one operation affects only few cells. Maybe think of the grid in some way such that one operation only affects a few cells. Yeah. Again, it feels a bit weird what exactly I'm saying, right? Like, how would you transform the grid into something? But
So
basically,
do you
this
mean
is
something like representing the cell? Instead of representing the cell, we should represent the sum of moves done above
yeah,
the cell.
something around that. So some way we represent a cell as some summation or something of its surrounding, such that in one operation only a few cells are getting affected eventually. So suppose say for now if I flip this cells, all the cells in this grid will get changed, right? How can I represent a cell as something such that only its surrounding gets, or like only few cells get affected when the operation is done?
If we are ignoring the bottom right move, then we can just represent it in a single cell, right?
Okay, I guess for now just let's remove about the three opine operation. Let's not take it into consideration. Just try to see what we can do with the one operation.
Yeah, so incrementing, suppose n comma m will represent incrementing every cell in 1 comma 1 2 m comma n.
Okay, so suppose initially this cell was black, right? I will just transform it here. So
Oh, I got it now what you mean. Yeah.
okay. So what? So basically now in this new cell, when would this be black for you? Or when would this be black? So this is the original grid on the left side. We want to look at in some different way, such that one move of changing a subrectangle in the original grid changes only a few cells in the new grid. So we will apply some transformation. It's a bit counterintuitive. I definitely get it, but it's something you will get with these are kind of concepts which are a bit difficult to think on, but if you know it, you can apply in more and more problems. So you apply some transformation such that in the original grid, when you do an operation of say something like this, in the resulting grid, only a few cells are getting affected eventually. So you got what I'm saying, right? What I mean to say. If you apply a
Yeah, I got that.
transformation, and it's such that when you apply a operation in the original grid, it changes only a few cells in the new grid. So maybe I will just write it up for more clarity. So there is A, and we applied the transformation and it became A prime, right? Now suppose we apply an operation on A. We apply an operation on A and it becomes B. Now we know that there are a lot of changes in it. A lot of changes will done equal to x into y, the grid of the length of the subrectangle. But we want to apply this transformation in such a way that now if we transform B and it's B prime, so this is eventually like applying applying the operation on A prime. Then A prime and B prime have a bit less difference in the number of cells which get flipped. So this is, I guess, more or less I want to say. I know it might not be very intuitive. If you don't get it, it's fine as well. But if you get it, I guess you would have some idea of what we want to do. So what we will do, I guess, it's a bit again very counterintuitive and like not something you can come up with yourself. So, but yeah, I guess this is one of this is an aim of the for now. We have to find a transformation. So basically now our problem is to find this transformation. Find a transformation such that whenever an operation like this is applied on the original grid, only a few cells get affected in the new grid. And yeah, again, after the transformation, not it might be the case that these cells are not black or could be black. Yeah. So we need to find such kind of a transformation. Does anyone have any intuition of what the transformation could be? Kritik, can you unmute yourself?
Hello?
Do you solve this problem?
No, bro, I haven't seen that problem before.
What?
I've never seen the problem before, bro.
Okay. So did you got till here like 2 and 4 operation will not be there and it's equivalent to convert from this grid to all white?
Yes. I understood till the part where you talked about the transformation.
You got it?
I got it till the part you talked about transformation, transforming this array.
Okay. So we need to transform it into a new grid such that an operation of this kind on the original grid would change only a few cells in the new grid. Do you understand this part? Like what we want to do?
Yes, bro. I understand what we want to do, but
okay. Do you have some intuitions of what we can do to achieve this? What kind of things won't get changed when a lot of things are flipped? Okay. Suppose there is a cell like 1 0, like 1 means black and 0 means white. And now suppose you flip both of these cells. It would change 0 and 1. Is there something which has remained constant from here to here?
the number of ones and number of zeros.
Okay, so the number of ones were 1 here and number of ones are 1 here again.
Yeah. But generally the count will be swapped.
What?
When you swap, the number of ones will become the number of zeros, and the number of zeros will be the number of.
Yeah. Suppose they were 1 1 originally and 0 0 here. is there something which is constant after the operation? Like in the previous operation, number of ones were constant.
Is it like a difference?
But the difference isn't constant, like -1 to 1 in the 0 1 case. Or maybe consider something like 1 0 1 and it gets flipped to 0 1. What is constant in these two? This thing I can at very answer. Okay, there are hand raised. Yeah, Aravind, Annamalai, you can.
Yeah, like the XOR of all these.
Yeah. Very good. Yeah. So basically, the XOR of this, which is basically the number of ones that are there here, the parity of the number of ones that are here would remain the same. There are 3 ones, which is like the XOR of which would give you 1, is same as 1 here. And when there was 1 as well, again, so basically XOR is summation of the digits mod 2. So summation here would be 3 and 3 mod 2 is 1, and summation here is 1 again and 1 mod 2 is 1. But this is something which would only be when there are even number of elements. For suppose there were 3, then it would be 0 here and 1 here. So in fact, when we have odd elements, the XOR of it would always flip when they're odd. But if you want to do something such that the elements don't change a lot. So maybe if we represent a cell as XOR of a few elements, then a lot of elements neighboring to it might change. So then it may not change. I guess after this, one thing I guess which could be thought of is what if we represent a cell as the XOR of it and its right cell. So XOR of 0 0 would become 1, XOR of 1 black and XOR of 0 0 would become 0, XOR of 1 1 would become 0, and 1 0 would be 1 and 0 1 would be 1. So suppose we apply this transformation that we change two neighboring cells, like we represent a new cell as the XOR of this cell and its right neighbor. So then this would change to, suppose we apply that transition to this grid, then what would happen? These are all 0, only these are the blacks. So everything else would remain 0 again. This would again become colored because XOR of this and this is this cell. So this would become black. XOR of this and this is black, like 1, so this would become black. Like I guess I'm interchangeably using white as 0 and 1 as black. This would become black, this would become black, this cell would again become black, this cell would become white because because this was black and this was black, so this would become white, this would become white as well, because it is XOR of this and this, and XOR of this and this would be just this cell, right? Is everyone here with me till, like, is everyone with me here? Okay. Kruti, did you got what we do? What we did?
Yes, bro.
Okay. Do you think the cells I have marked black are correct, or is there something I am missing? Will there be some other cells which would also become black, or I marked some cells wrong?
I don't think so.
Yeah, I also don't think so. I hope this is correct. So these are the things that got changed. One more question, Kruti. Now, what do you think would happen when we apply the operation on the original grid? What cells in the new grid would get changed? So let's consider, let's go step by step. So what would happen to some cell? Suppose this is the operation we have made. What would happen to this cell? Will it get changed? It's the XOR of this and this.
No,
Both of them. Will it change?
it won't change.
It will not change, right?
Yeah.
this cell,
I won't change.
so all of these cells won't change, right? Because both of these, all of these cells in this new grid won't change, right?
Yeah.
Okay. All the cells in this row, this column.
Wait, the left neighbors of x's will change, right?
What?
The left neighbors of x.
I couldn't get you.
I'm sorry. Left neighbors of x mark cells.
Left neighbors of x will change.
Yeah.
Okay. Why? Okay. So suppose this is what I considered, right? So this was 0 and 1, right? After I apply the operation, it will change to 1 and 0.
Wait, I'm sorry. It won't change. It won't change. It won't change.
So basically, in this new grid, each cell is XOR of two elements. And if both of them are flipped, that particular cell won't change.
Yes, yes, yes.
Okay? Irrespective
Yeah.
of whether they are black or whether they are white. Because
Yeah.
XOR, if XOR of a length of even elements, if all the elements will be flipped, then the XOR won't change.
Yeah. So the
So which
elements in
elements
the
will get
rightmost
changed?
column will change.
Yeah. So all the elements in the rightmost column will change, right?
Yes.
Okay. So these are the elements which will get changed. So probably, suppose in the new grid, I represent it as I represent it as like this. Because this, yeah, I guess this. So now in this cell, in this grid, only these cells will change. Only the cells which are at the right end, because for these cells only one of the two elements was flipped, and if in a two element, or if in like if you're taking an array of two elements, and if you just flip one of the element, then its XOR will obviously get changed. So since you change just one element of these XOR will get changed, and now the final grid after the operation would look something like this. So these cells get black, and this would be a complete mess, like a lot of would get changed and all. But in this grid, only these cells will get changed. Do you agree, Pratik?
Yes.
Okay. So now from changing x into y element at a time, we are only changing say y x elements at a time, right?
Yes.
But still they are of great order, like they are not constant like 1, 2
Yeah.
or 3. Now can you think of something else which would change of only few elements with each operation? So this was one thing which I guess I don't remember the name. That guy suggested, and it was nice. So if we take two elements, their XOR won't change with the flip. Can we represent it something else? The operation, the transformation. Aditya, can you unmute? What do you think you can do?
Maybe use this as an intermediary matrix and get something from here.
I want to make a transformation such that only a few elements gets changed. So tell me what would happen if we consider a cell as the XOR of this box. So suppose for a cell here, this cell, we represent it in the new grid as the XOR of its right element, the element below it, and the element on the southeast of it. If we represent the element as the XOR of these four elements, you get it right? With
Then only the bottom
which element
right
would
will change.
Okay, so all the elements won't change because all the elements inside won't change because they are like there are four elements and all the four elements got flipped, so they won't change at all. Elements on the border, something like this, for them
Those
as
also
well, only two elements got flipped, which is like changing XOR twice, which results in the same XOR. So all the elements here won't change. Similarly, all the elements here, and here won't change. Only for all these, 2 or 4 cells got swapped, so their XOR value won't change. Only the cell uh, uh, for which the XOR value did change was this, right?
Yeah.
Cells which are here, the XOR value won't change. Other cell, the XOR value won't change. Just this cell. So now in the equivalent grid, one operation of type this is equivalent of changing just one cell.
One element.
And now we can easily say if your operation is of like changing just one cell, how many minimum operations will it take for you to make the grid completely white?
And at most, if all went from black to white.
So yeah, so like if there are, if you know the configuration of this grid, so basically from this grid, you will construct the transform grid, which is basically the XOR of the four values. And now consider that this grid looks something like this. Yeah. And now how many operations will it take for you to convert this grid to all white?
Number of operations meaning the changes that we have to do.
Yeah. The number of operations to convert this grid to all white, the transform grid.
So order of number of black cells?
Like exactly how many it will be. Like in one operation, you can change one black to 0 or one black to white or one white to black. And you need to convert these all to white.
So this is the number of black cells, right?
Yeah. So it would be number of black cells, right? So we have 4, 5, 6, 7, 8, 9 black cells. So in 9 operations, you can convert it back to all white. Did you get it?
Okay, so we are defining an operation that to be converting black to white, right? It's not the initial operation that we had.
Yeah, now we had converted that, right? Like now we have this converted grid. We know that one operation here is equivalent of converting just one particular cell here from black to white, right?
Okay. Okay.
I guess it's a bit still hard to understand. So maybe yeah, you guys can just put a bit like of like try to do it up by hand, that what exactly happens and why it's happening. But this is what happens. So eventually, without the three thing, so I don't think we have the time to go into the three operation part. But if we don't have the three operation, you transform this grid to the XOR of the four values, and now in the transform grid, to convert it to all white, this transform to all white would take you, the cost would be the number of black cells, exactly number of black cells. And in number of black cells, you will be able to convert this to white, and the white cell in the new grid would also be the white in the original grid. So I guess for just one operation, the answer would be the number of black cells in the transform grid. Okay. I guess it was a bit hard problem. So it just takes some time to get to get familiar with what exactly is happening. But I guess that main thing in this problem was to convert this operation into something, or like to convert the grid into something such that one operation only changes a limited number of cells. That was the main part of it. Okay. I guess it was a bit hard problem. Maybe you can just try it out once. Just try to see why it works and all. And I guess it would become a bit clear. I just tried my best to show you what exactly is happening, but again, yeah, I do accept that why you take that XOR of 4 thing is a bit non-intuitive. You can't think of it or something. But once you know that this thing that changing this one operation here is equivalent to just changing one cell here is kind of the what was the golden part of this problem, that you change the gate into something such that an operation that was changing a lot of cells here is just changing one cell here. Okay. I had one more question, but I think we don't have the time to go into it. Again, this was a hard problem, so like I don't think we would be solving this kind of problems in the like G2. This was just something to like interact and have a bit of fun. I hope you guys got some insight of the solving the problem. I'm not sure if you got exactly all what I was saying. So yeah, I guess um, for more sessions, for more problems, you can join WPS G2. In WPS G2, we will definitely be solving a bit easier problems than this. Does anyone have any queries regarding the problem or regarding G2? Yeah. Any queries regarding G2 or the problems to solve? If you still have any queries and you want to speak, you can stay. I guess else we will end the session. Bye bye, everyone.